In a diode, we can make the N-type side more negative by connecting it to the negative terminal of a battery, and the P-type side more positive by connecting it to the positive side of the battery. When we do this, we force lots of extra electrons and holes into the junction. The electrons in the N-type region near the junction are repelled by the electrons of the atoms of the P side of the junction. However, they're also repelled by the other electrons drifting around inside the N-type material. When we shove extra electrons into the N-type material, we increase the number of electrons pushing from this side. This works a bit like pressure in a gas. Electrons near the junction are helped across the junction by being shoved from behind. The effect is to reduce the amount of extra energy required to cross the junction. In other words, the height of the energy barrier, or kink, reduces, and electrons can move freely towards the positive terminal of the battery. In the same way, holes can move from the P-type material across the junction towards the negative terminal of the battery. When we connect the P-type end of a diode to the positive terminal of a battery and the N-type end to the negative terminal, like this, we say the diode is connected with a forward bias. Look at what the ammeter and voltmeter readings are when the diode is connected with a forward bias. But if we change the electrodes around, the ammeter reads 0 amperes and the voltmeter shows a negative reading. This arrangement is called a reverse bias. Let's see why no charges are moving across the P-N junction now. The holes in the P region move away from the depletion region towards the negative terminal of the battery. In the N region of the diode, the extra electrons are pulled away towards the positive terminal of the battery. This increases the force of repulsion of the ions and stretches the depletion area, making it very difficult for charges to move over the junction. So charge cannot flow through the circuit. I hope you can see that for low potential differences, a diode is a very effective way of controlling the direction of current. Current can only pass across the P-N junction when the diode is connected with a forward bias. But remember that if a very high potential difference is applied across an insulator, electrical breakdown can take place. This is also true for a reverse bias diode. A high potential difference will force charge across a P-N junction, even if a diode is connected with a reverse bias.